today I am going to start new chapter, Determinants, that is fourth chapter. So in that chapter, there are 12 marks coming in annual examination. So one 5 marks question, one 4 marks question, one 2 marks question, one 1 mark question. So total 12 marks. So this is very important. Next, what is the, so in this chapter we discuss what is the meaning of a determinant, what are the properties of a determinant, next area of triangle, that is the application of derivatives, next minors, cofactors, adjoint of a matrix, and finally solution of system of linear equations in matrix method. So these are the topics we will discuss in this chapter. Let us see first what is the determinant. To explain the concept of determinant, let us see first system of equations. A1x plus b1y is equal to c1, a2x plus b2y is equal to c2. So this system of equations can also written in the matrix form as ax is equal to b, where A is matrix a1 b1 a2 b2, that means coefficients of xy in first equation right in first row a1 b1, coefficients of x and y in the second equation right in second row a2 b2, and matrix x is variables. What are the variables involving this equations? X and y. So x, y, two variables. Next is equal to b. Here b is the matrix of constants, that is c1 c2. So if we multiply this and equating corresponding elements, so we get a1x plus b1y, a2x plus b2y. So that is, so in LHS matrix multiplication, first row with first column, so that is a1x plus b1y, and second row with first column, so a2x plus b2y is equal to c1 c2, c1 c2. By equality of matrices, equating corresponding elements, a1x plus b1y is equal to c1, a2x plus b2y is equal to c2. So therefore the system of equations a1x plus b1y plus c is equal to c1, a2x plus b2y is equal to c2 can also express in the matrix form as ax is equal to b. So that is a1 b1 a2 b2. Here matrix is obtained, this matrix is obtained by coefficients of xy in two equations. Next, the xy are the variables, c1 c2 are the constants. So therefore this system of equations can also be expressed in matrix form as this one. So therefore, in 10th standard, the system of equations has unique solution. What is the condition? A1 by A2 is not equal to B1 by B2. So this implies A1 B2 is not equal to A2 B1. So this implies A1 B2 minus B1 A2 or A2 B1. B1 A2 is not equal to 0. If this number is not equal to 0, here A1 B2 minus B1 A2 is not equal to 0, the system of equation has unique solution. So therefore the number A1 B2 minus B1 A2 which determines the uniqueness of a solution is related to or is associated with the matrix a1 b1 a2 b2. So this number a1 b2 minus b1 a2, so this number associated with this matrix a1 b1 a2 b2, therefore this number is called the determinant of a matrix a1 b1 a2 b2. So determinant of matrix A is denoted by this symbol or det A or delta. So So these are the notations of determinant of matrix. So once again, a system of equations. These two representations are same. So therefore, system of equations has a unique solution or not. So which determines the number a1 b2 minus b1 a2 is not equal to 0. So this number is equal to 0. The system has no solution with not unique solution. If this number is not equal to 0, the system has unique solution. So therefore, so this number, the number a1 b2 minus b1 a2, which determine the uniqueness of a solution, is associated with the matrix a1 b1 a2 b2. That means every square matrix, every square matrix, we can associate the number a1 b2 minus b1 a2. So this number may be real or complex. So this number is called the determinant of a square matrix. Therefore, we define determinant of a matrix as, so to every square matrix we can associate a number. That number may be real or complex. Is called the determinant of matrix A. So determinant of matrix A is denoted by, so this can be written as determinant of A not modulus of A. So this is not absolute value. So this is determinant of matrix A or det A or delta. So determinant of matrix is always denoted by, so determinant of A or det A or delta. Therefore, so how to get the number a1 b2 minus, so if we cross multiplication a1 b2 minus a2 b1, so this number a1 b2 minus a2 b1, so this number is called the determinant of the square matrix. This is obtained by product of the principal diagonal elements of square matrix minus product of the other diagonal. So that is a1 b2 minus a2 b1. This number is called the determinant of a matrix A. Now, so what is the definition? So determinant, to every square matrix is associated with a real number. That number is real or complex, is called the determinant of a matrix. Next, how to find the determinant of matrix of order 1? Suppose here A is equal to so A11. So this matrix contains one row, one column. So this matrix contains only one element. Determinant of this matrix containing one number. That means determinant of a matrix of order 1. So this implies determinant of A is equal to, so this symbol is determinant. So determinant, matrix totally different. Determinant write in two vertical lines, matrix write in brackets. So that is the difference. So very important point. So determinant always write in between two vertical lines. So that is A11. So determinant of A is determinant of A11. Determinant of A11 is, so itself. So therefore determinant of a matrix of order 1 is the element itself. For example, determinant of 5 is the number itself. So therefore this is the determinant of a matrix of order 1. Next, determinant of a matrix of order 2. Determinant of a matrix of order 2. Let A is equal to general 2 by 2 matrix A11, A12, A21, A22. So this is the given matrix. Determinant of a matrix is this one. Determinant is writing two vertical lines. So A11, A12, A21, A22. So this value is obtained by product of the principal diagonal minus product of the secondary diagonal. So that is, this determinant value is obtained by product A11 into A22 minus A21 into A12. So this value is the determinant of this matrix A. So for example, example 1, find if A is equal to, so 1, 2, 3, 4 implies determinant of A is determinant of 1, 2, 3, 4. How to obtain the value of determinant? So product of the principal diagonal elements. So that is 1 into 4 minus 2 into 3 into 2, that is 3 into 2. The value is 4 minus 3 2s are 6. So 3 into 2. So 3 into 2. So 4 minus 6, the value is minus 2. So therefore, this number is related to, is associated to the square matrix C. So that what is the definition of determinant? Yeah, to every square matrix we can associate the number. That number may be real or complex. Therefore, this minus 2 is a real number. This number is associated to the square matrix A is equal to 1, 2, 3, 4. This number minus 2 is called the determinant of this matrix A. Here A is equal to 2, 4 minus 8, 6 implies determinant of A is product of the principal diagonal. So first write in determinant. So 2, 4 minus 8, 6. Write in vertical columns. So product of the principal diagonal elements, that is 2 into 6, 12 minus 8 into 4 minus 32. So that is 12 plus 32, minus into minus plus 32. 32 plus 12, 44. 44 is a real number. This real number is associated with the square matrix A. So 2, 4 minus 8, 6. So therefore, to every square matrix we can associate a number. So this number is called the determinant of that matrix. Suppose B is equal to 2, 4, 4, 2. 2, 4, 3, 6 implies determinant of A is equal to 2 into 6. So that is 2, 4, 3, 6. So that is product of the principal diagonal elements, that is 2 into 6, 12 minus 3 into 4, 12. The value is 0. Here 0 is a real number. This real number is called the determinant of this matrix B. So this is the method to find the second order determinant, second order matrix, determinant of a second order matrix. Okay. Next, how to find the third order determinant? So determinant of matrix of order 3. So let A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. Clearly, this is a square matrix of order 3. Square matrix of order 3. How to find the determinant of matrix of order 3? Suppose if A is equal to 3 by 3 matrix, determinant of a matrix of order 3 can be expressed it in terms of second order determinants. This is known as expansion of a determinant along a row or column. Suppose this can be the determinant of A is equal to determinant of A11, A12, A13, A21, A22, A23, A31, A32, A33. So this is obtained by expressing it in terms of second order determinants. Here first A11, this is known as expansion of a determinant. Expansion of a determinant along a row or column. So there are six ways we can expand the determinant of third order matrix along R1, along R2, along R3. We can expand along R1, along R2, along R3. Or we can expand along column 1, along column 2, along column 3. So therefore, we can expand third order determinant in 6 ways. 6 ways associated to 3 of which are rows and 3 are along with columns. So therefore, third order determinant can be expressed or expanded in 6 ways. So I can expand along with row 1, expand along R1, expand along R1. So we get here A11 along R1 means, so this is row 1. Here row 1 elements are A11, A12, A13. Here A11 is first row, first column element. So multiply first row, first column, minus 1 to the power of. Here A11 is first row, first column element, minus 1 to the power of 1 plus 1 into here first element, take first element A11 into determinant of, okay na, here A11 is the first row, first column element, the sign is minus 1 to the power of, here 1 plus 1 means here the A11 contains in first row, first column. So that's why minus 1 to the power of 1 plus 1 into A11 into here A11 is the first row, first column. So delete first row, first column, or leaving first row, first column elements. So you get remaining 4 elements. Determinant of these 4 elements. Determinant of A22, A23, A32, A33 plus next A12 is the minus 1 to the power of, here A12 is first row second column element, minus 1 to the power of 1 plus 2 into A12. Here multiply A12 with minus 1 to the power of, that element contains row and column. So minus 1 to the power of 1 plus 2 into A12. Here delete here A12 contains first row, second column. So deleting first row and second column elements. So we have remaining 4 elements, A21, A23, A31, A33. So determinant of A21, A23, A31, A33. Next, A13 plus minus 1 to the power of, here A13 contains first row, third column. So minus 1 to the power of 1 plus 3 into multiply that element A13. So here A13 is belongs to first row and third column. Delete first row and third column elements. What are the remaining 4 elements? A21, A22, A31, A32. So how to expand the second order determinant, you know already. So minus 1 to the power of 1 plus 1, A11 into determinant of this. So therefore every square matrix of order 3 can be expressed in terms of second order determinants. This method is known as expansion of a determinant along a row or along a column. So I can expand along R1. So we get this one. So this one. So next, suppose expand along R2. So we can expand along R2 or along R3 or along C1, C2, C3. We can expand third order determinant in 6 ways. So 3 expanded along with rows and 3 columns. Right. So here expand along R2. Suppose we can expand along R2. Here A21. So that is A11 is first row. That is minus 1 to the power of. Here A21 minus 1 to the power of 2 plus 1 into multiply that element A21. So second order determinant. So that is here A21 is second row first column element. Second row first column. So delete second row and first column. What are the remaining 4 elements? A12, A13. Next, A32, A33. Next, plus along R2. So that is second element is A22 minus 1 to the power of 2 plus 2 into multiply that element A22 into second order determinant is obtained by deleting A to 2 is contains in second row, second column. So deleting second row, second column elements. So we get the remaining 4 elements are A11, A13, A31, A33 plus minus 1 to the power of here A23 minus 1 to the power of 2 plus 3 into multiply that element A23 into multiply determinant of here A23 is second row third column element. Delete second row and third column. Remaining 4 elements are A11, A12, A31, A32, A11, A12, A31, A32. So we can expand along R2. So this is the determinant. Or we can expand along R3. Again we get the another expression. In all the cases, or expand along C1, along C2, along C3. In all the cases, it gives the same value of this determinant. So it gives the same value. So expand along R1, no problem. Along R2, along R3, or C1, C2, C3, no problem. So we can expand along anyway. In the we have 6 ways. We can expand any one of that one. So these are the two. So expand along R1, we get this expression. So expand along R2, we get this expression. Next, one small clue. So minus 1 to the power of 1 plus 1, even number. What is the sign? Minus 1 to the power of even number is plus. Next, minus 1 to the power of 1 plus 2. Suppose these are, so expand along R1. R1 element signs. Okay, now minus 1 to the. Here A12 is first row, second column element. Minus 1 to the power of 1 plus 3. Minus 1 to the power of 3, odd number. That is minus. Next, minus 1 to the power of 4, even number. That is plus. Similarly, suppose if we expand along R2, what are the signs? Minus 1 to the power of odd number. Minus. Next, minus 1 to the power of even. Plus. Minus 1 to the power of 5. Minus. Similarly, if we expand along R3, here A minus 1 to the power of 3 plus 1, 4. That is even, plus, minus, plus. So these are the signs. So these are the signs associated to the elements of third order determinant. So plus, minus, plus. If we expand, suppose in next problem onwards, so no need to minus 1 to the power of 1 plus 1. Just you multiply first row elements with signs. This is minus, sorry, this is plus, this is minus, this is plus. Suppose if we want to expand along R2, so we take directly the signs are, so first row element sign is minus, second element sign is plus, third element sign is minus. Suppose if you want to expand along R3, so take directly the signs are plus, minus, plus. Suppose if you want to expand along column 1, what are the signs? Plus, minus, plus. So column 2, minus, plus, minus, plus, minus, plus. So I will explain detailedly in one example. So in all the cases, expand along R1, R2, R3, or C1, C2, C3. So we get the same value of a determinant. So determinant value, no change. Suppose see one example. If A is equal to 1, 2, 3, minus 1, 4, 0, 2, 1, 3. So find determinant of A. So this is the question. So find the determinant of A. Here given matrix is 3 by 3. So determinant of A is denoted by this one. This is not read as modulus of A. So just this can be read as determinant of matrix A is determinant of 1, 2, 3, minus 1, 4, 0. So 2, 1, 3. So I want to expand R1. So we can expand R1 along R1, along R2, along R3. So I already given signs. What are the signs associated to the third order determinants are plus, minus, plus, minus, plus, minus, plus, minus, plus. So these are the signs associated to the elements of third order determinant. So therefore, if we want to expand along R1, so write the signs plus, minus, plus. So because I want to expand along R1, so write so minus, no need to write minus 1 to the power of 1 plus 1. So just you multiply signs only. Here sign is plus, okay na? Sign is plus 1. A11 element is 1 into determinant of, here delete first row and first column elements. So delete first row, first column elements 4, 0, 1, 3. Next, sign is minus, element is 2, that is minus 2. Minus 2 into, here minus 2 is first row, second column element. Delete first row and second column. So delete first row and second column. So we get minus 1, 0, 2, 3. And 3 plus 3. So take plus 3. Here plus 3 is first row, third column element. Delete first row and third column. So these are the remaining 4 elements, minus 1, 4, 2, 1. Determinant of minus 1, 4, so 2, 1. Expand, that is 1 into, so 4 multiply principal diagonal elements, 4 3 are 12, minus 1 into 0, minus 2 into, minus 1 into 3, minus 3, minus 2 into 0, plus 3 into, minus 1 into 1, minus 1, minus 2 4 are 8. So if we simplify this, 12 minus 0, 12, 12 1 are 12, minus 2 into minus 3, plus 6, so minus 9, plus into minus, minus 27. So the value is, so 20, so 12 plus 6, 18, 18, so minus 9. So that is the value. So this number is called, this number is associated to the third order square matrix. This number is called the determinant of this matrix A. Suppose I want to explain, I want to expand column 1 or column 2 or column 3 also. Suppose expand, here expand by R1. Next, expand along column 1. Expand along C1. Suppose what we will get? So expand along C1. Here column 1 means expand along C1. So this is the column 1 elements. What are the signs? What are the signs associated first column elements are plus, minus, plus, plus, minus, plus. Here 1 sign is plus, minus, plus. Signs associated to the first column elements are plus, minus, plus. Here plus 1 into, delete first row and first column. Here 1 is first row, first column element. Delete first row and first column. Determinant of 4, 0, 1, 3. Next, here minus into minus 1. So element minus into minus 1. Here minus 1 is second row, first column element. Delete first, second row and first column. 2, 3, 1, 3. Determinant of 2, 3, 1, 3. Next, plus 2 into, plus element is 2 into determinant. Here 2 is third row, first column element. Delete third row and first column. So determinant of 2, 3, 4, 0. 2, 3, 4, 0. So therefore, here 1 into 4, 3 are 12, minus 0, minus into minus plus 1 into 2, 3 are 6, minus 3, plus 2 into 0, 0, minus 4, 3 are 1. So that is 1, 12 are 12, plus 6 minus 3. 6 minus 3 is 3. 3 into 1 is 3 plus 3. Next, 2 into minus 12, minus 24. Minus 24. So that is 15 minus 24. So that is minus 9 again. So see this. So if we expand along R1, R2, R3, RC1, C2, C3, the value of determinant remains same. The value of remain always same. We get the same value of determinant. So no problem. So in any way we can expand third order determinant. So conveniently, suppose in the third row this is 0. So 0. Suppose a third row is 0. If A is equal to. So determinant of A is equal to 1, 2, 3. Right. 1, 2, 3 minus 1, 4, 0. So 2, 1, 0. For easier calculations, we can expand the determinant along C3 because if C3 contains more number of zeros. For calculations, we can expand the determinant, that row or column which contains more number of zeros. Or no need, so we will convenient diagonal, so no problem. So we can expand along R1, R2, R3, no problem. So we can get we will get the same answer. But for easier calculations, we can expand along C3 because your column 3 contains more number of zeros. So that's why for easier calculations we can expand row or column which contains more number of zeros because your third column contains more number of zeros. I can expand along C3 expand along C3. Here what are the signs associated with third column elements are plus minus plus, again plus minus plus. So these are the signs associated with the third order determinant. So therefore here plus element is 3 into determinant of, so second order determinant. So here 3 is the first row third column element. Delete first row and third column. So remaining elements are minus 1, 4, 2, 1. Next sign is minus, element is 0 into determinant of, if 0 is second row third column element, delete second row and third column. So remaining 4 elements are 1, 2, 2, 1. 1, 2, 2, 1 plus element is, sign is plus, element is 0. Determinant of, if 0 is third row third column, delete third row third column elements 1, 2, minus 1, 4. So here 0 into, we know that 0 into anything is 0. So these two becomes 0, 0. So therefore simple 3 into determinant of these two. Second order matrix, second order determinant. Minus 1 into 1 is minus 1 minus 2, 4, 38. So that is 3 into minus 9. So that is minus 27. So you get this answer easily. So otherwise we can expand R1, no problem, plus minus plus, expand 1 into delete first order first column elements, so get the second order, minus 2 into second order element, plus 3 into second order element, you get the same answer, minus 27. So expand along R1, R2, R3, R C1, C2, C3, so we get the same answer. For easier calculations, we can expand the determinant with a row or column which contains, which row or column that contains maximum number of zeros. Which row contains maximum number of zeros or which column contains maximum number of zeros, we can expand that row or that column. So clearly your column 3 contains more number of zeros, so that's why I can expand so along C3. So get the answer minus 27. So for easier calculations, we can expand 6 ways, no problem. So we get, in all the cases, that gives the same answer. So this is the method to find the third order matrix determinant. Right. So let us see some examples. The exercise 4.1. Evaluate propagate the determinants. The question number 1, determinant of 2, 4, minus 5, minus 1. So this is the determinant of a matrix of order 2, determinant of a matrix of order 2. So we know that how to expand second order, how to calculate the determinant of second order square matrix. So that is